of areas related to circle, and actually today is the last day to complete this chapter. Okay, only 3 sums are left. Some of the 1 or 2 sums require time. So let's start with that. Last we have completed up to question number 13. So today we will start from question number 14. So question number 14. What is the sum? Once you read it, AB and CD are respectively the arcs of two concentric circles of radii 21 cm and 7 cm in center O. An angle AOB equal to given 30 degree. We have to find out the area of the shaded region. It's very easy to come. Let's draw the diagram. We have to find out the area of the shaded region. They are given O, C, D, A, B. This one given total 21 centimeters. So radius of this sector, bigger sector radius is 21 centimeter, smaller sector radius is 7 centimeter. This angle is sacred angle is 70 degree. See, from this bigger sector, if we subtract this smaller sector, then we will get the area of the shaded region. Very easy sum. So area of shaded region, therefore, equal to area of sector OABO minus area of sector OCDO. Sectorial angle is already 30 degree for both the bigger sector and smaller sector. So it will be 30 degree by 360 degree. Pi into r square means 21 square because bigger one we have taken first. So first we have taken the bigger one. So 30 by 360 into pi into 21 square minus smaller sector area 30 degree by 360 degree into pi into 7 square. So this much centimeter square. Pi, no approximate value of pi has given, so you have to put pi equal to what? 22 by 7. So 30 degree by 360 degree we can take as common. Pi also we can take as common. So it will be 21 square minus 7 square. So I think we can apply a square minus b square formula as a minus b to a plus b. Doing the cancellation. Pi mean you put 22 by 7 and here a square minus b square mean I think you can do it yourself. So the leftover calculation part you complete yourself and find out the final answer. Okay? I'll move to question number 15 now. Question number 15. In the figure, ABC is a quadrant of a circle. Okay. A, B, C is a quadrant of a circle of radius 40 centimeters. So this quadrant radius is 40 centimeters. And the semicircle is drawn with BC as diameter. With BC as diameter, a semicircle has drawn. Find the area of the shaded region. So these are also 40 because radius of the quadrant. We have to find out the area of the shaded region. The shaded region is this one. Now look here. First of all, to find out the area of the shaded region, I need to find out the area of the semicircle. Correct? The area of the semicircle, first of all, I have to find out with BC as diameter. So if I can find out the area of the semicircle, and from there if I subtract the smaller part, smaller unshaded part, then only I get the area of the shaded region. Is it? So from this semicircular area, if I subtract the smaller unshaded part, then only I get the area of the shaded region. That is my question actually. But if I want to find out the area of this semicircle, then I need the radius of this semicircle. What is the radius of the semicircle? That one I need to find out. Radius of the semicircle I can find out if I can get the length of BC, because this is the diameter of the semicircle. And by doing diameter by 2, I can find out the radius of the semicircle. So my first work to find out the length of BC, because BC will be the diameter of the semicircle, and by doing half of that I can get the radius of the semicircle. And if I can get the radius of the semicircle, definitely I can find out the area of the semicircle. Correct? So let's start. BC equal to root of 40 square plus 40 square. So root of 2 into 40 square. So it's coming 40 into 2. So this is the diameter of the semicircle. Therefore, radius of the semicircle, what will be? That is diameter by 2. This is 7 root 2 centimeter. So got the radius of the semicircle. And we got the radius of the semicircle, so I can find out the area of the semicircle. So therefore, area of the semicircle with diameter BC equal to pi r square by 2. So I think this calculation you can do yourself. Let's see. Pi equal to 22 by 7. I think no value of pi is given in question. 7 into 7 into 2. Because 7 square means 7 into 7. Root 2 square means 2. So 154. So you got the area of this semicircle. Now I need to get the area of this unshaded part. How will you get it? From this quadrant area, properly see, from this quadrant area, quadrant is ACBA, this quadrant area. So from this quadrant area, if I subtract the area of this triangle, area of this triangle, if I subtract, then I will get the area of this unshaded smaller part. So what we will do? There we are giving the name of the region as 1. Okay. And we are writing like this: area of region 1 equal to area of quadrant ACBA minus area of triangle ABC. Now quadrant area you already know, pi r square by 4. So it will be pi r square is 40 square by 4, because pi into radius square by 4. Quadrant into 1/4 of a circle you already know. Now area of triangle ABC is half into base into height. Base is 40, height is also 40. So 40 square you can take as common. Pi means 22 by 7 minus half. I think this calculation part you can complete yourself. First of all, you do the cancellation. After that, do the multiplication, do the LCM, whatever the cancellation is possible, numerator, denominator, that all the things you do, and then find out your answer. Okay? So the leftover calculation part I think you can do yourself. So if you do so, then you will get the area of the region 1. So what the answer you will get? So find it out first. Okay? Then what the next part I will say now? That one you do. So when you got the area of the region 1, so this region 1 area, now if I subtract from the semicircle, then I get the area of the shaded region. Better you can understand from this semicircular region, if I subtract the area of region 1, definitely I will get the area of the shaded region. So for that what will be? Therefore, area of shaded region equal to area of semicircle minus area of region 1. Area of semicircle already we got 154 centimeter square, and area of region 1 you are just finding here. So that value put here, and after that you do the subtraction to get your final answer. Okay? Do you remember one thing? If here actually cancellation is possible, suppose here cancellation not completed properly, and came your and you are just searching your answer, and suppose you got your answer in the approximate way. But I say that such type of things you don't do. If your division is not yet completed here, do not find out your answer as an approximate one. Keep it as fraction. Put that value here because this is not your last step. Whatever the answers you are getting here, if you can get your answer as a terminating decimal number, no problem. If you are getting your answer as a fraction, no problem. But do not find out your answer as an approximate one. Suppose division is not possible, so you have got your answer in the approximate one, and you are just writing over this one, correct up to 2 decimal places. So don't do like that. Whatever the answers you got here, without finding out the approximate value, put that direct value here. Complete the calculation, and then if you see at the last step also you are getting a fraction wherever the division is not possible properly, then you can find out the approximate result, no problem. But the approximate value should not put in the sum again to find out the approximate result. Then there will be 2 errors, and for that error the marks can be deducted. Am I clear? Because this is not your final answer. Your final answer is this one, to find out the area of the shaded region. But this is required to find out because this area of the region 1 you are just subtracting from the semicircle to get the area of the shaded region. Clear? So complete this calculation, and after then put this value and complete this one. I think you can do it yourself. Now we move to the last sum of our this chapter, that is question number 16. Now question number 16. There is a design. Let's draw it first. This is actually a square. Each angle is 90 degree given. Two quadrants of circle are there. Look here. This is the one quadrant, and this is the another quadrant. I think you understand. Two quadrants of circle are there. Just throw in question asking what. This is one of the quadrant, and this is the another quadrant of circle. Okay. And we have to find out the area of the region between these two quadrants. So this region area have to find out, this shaded region. We have given some design here, but for our calculation purpose, we have drawn the diagram as a simple way. So how I can find out the area of the shaded region? Let's see one. Just I am giving the name of the square as ABCD, and we are joining this B and D. Now, if I want to find out the area of the region 1, properly see, if I want to find out the area of the region 1, first of all, I have to find out the area of the quadrant ABDA. Check it out properly. Which one? ABDA. First of all, I have to find out the area of the quadrant ABDA. And from there, I have to subtract area of triangle ABD. And if I do so, I get the area of the region 1. Correct? So to get the area of the region 1, first of all I have to find out the area of the quadrant ABDA, and from there I have to subtract area of triangle ABD. Then definitely I will get the area of region 1. And you better understand, both these quadrants are of similar kind, same, because both of them have the same radii. So that's it. This figure is symmetrical with respect to this line BD. So what is the area of region 1? That is the area of region 2 also. So finding out the area of region 1, by the way, whatever I have told. What way? First of all, I find out the area of the quadrant ABD. ABD is this quadrant area, and from there I subtract the area of triangle ABD, which I can find out easily because half into this into height is the area of right angle triangle. So if I do so, I get the area of region 1. From this quadrant, if I subtract the area of this triangle, definitely I get the area of region 1. And if I do the double upping, I get the area of region 1 and 2 together. That is the area of the shaded region or the design, whatever I have asked for in the question. So what we will do now? First of all, we will write area of region 1 equal to area of region 2. Why? Since both the quadrants have the same radius. Okay. Now, therefore, area of region 1. First of all, we find out area of region 1 equal to area of quadrant ABDA, and from there we are subtracting area of triangle ABD. Now, area of quadrant ABDA, quadrant formula you know, pi r square by 4, because 1/4 of a circle. Or you make an use 90 degree by 4, 60 degree pi square, no problem. Pi r square by 4 means pi into 8 square by 4. So we got the area of the quadrant ABDA. Now from there we subtract area of triangle ABD, that is half into base into height. This much centimeter square. Any value of I has given in question? Consider C. No. So you have to put the value as 22 by 7. I think the leftover calculation you can do. Do the LCM, do the subtraction, but do not find out your answer as an approximate way. Keep the fraction as your answer, no problem. Okay, keep your answer in fraction. So you got the area of region 1, and I have told at first area of region 1 is what area of region 2. So what is the question? Area of the shaded region, area of the design region. So what do you write now? Therefore, area of design region, that will be 2 into area of region 1. Because at first only I have told, then you can write by 1. Because at first only we told that region 1 area, region 2 area are same. So to find out the area of the shaded region or the design region, we can directly do 2 into area of region 1. So then 2 into area of region 1 you are getting here. So this answer you just put here, calculate and find out your answer. If required, you can find out your answer to kind of 2 decimal places here. But here you don't know, because this is not your final scale. So here no approximation should be done by you. Whatever the value you are getting, whatever it is fraction or whatever it is, so that value you put here. Calculate, then find out your answer. Either as a terminating decimal number, but you don't give your answer in fraction. If it is coming in fraction, give your answer in the kind of 2 decimal places. If it is an approximate one, or if it is a terminating decimal number, how many terminating decimal places required to find out the answer? Complete it. Okay. So we are just completing our chapter with this. This chapter completed. Now we will do from some extra sum from outside, whatever it is. And if you are facing any problem in any of the sum, anywhere, you can directly ask me the doubt clarification. Thank you all.